The linear equation of y equals mx plus b has a coordinate at at positive 1 and 8, 5, and 0. Now, when we solve a problem like this in grade 10, we usually found the slope. So we calculated slope by using the slope formula, and then we substitute it in to be able to solve for the b value or the y-intercept value. We could also solve this as a system of equations. Okay, so it would work out as a system of equations this way. Since we have two variables, m and b, we just need to come up with two relationships. And the two relationships can be generated by the two coordinates. The 1 and 8 are related to each other, so there's a relationship. 0 and 5 and 0 related to each other. So I'm going to do this as a system of equations. So I'm going to set up my system. Equation 1 is going to use the 8 and 1. So y equals 8 when x equals 1. Okay, so there's my two variables, m and b. I can use the second coordinate, y equals 0 when x equals 5. And again, I have the same two variables, m and b. So I have a system of equations. So this is slightly different than what you would have done before, and I wouldn't necessarily suggest that you do this particular problem this way, but notice that it does set itself up for a system of equations. We have two unknowns, 2 points which give us two relationships. So if I subtract equation 2, so equation 2 is going to be y equals 5m plus b. Okay, subtracting that is going to get rid of the b's. So I end up with 1 minus 5 is negative 4m's. So the slope works out to be negative 2. Okay, so there's the slope. When I substitute back in, I can solve for b. So I end up with 0 equals m is negative 2 times 5 plus b. b works out to be plus 10 on both sides. B works out to be 10. So this is exactly the same problem as we did in grade 10, except we set this up as a system to solve. Okay, and this is perfectly fine because anytime we have two variables, two equations, or two relationships, it's a system of equations and we can solve it using some system strategy.